Hello everybody, this is the first lecture of measurement and instrumentation course. My name is Amar Abdul Bari. I am with Nearest University, Department of Electrical and Electronic Engineering. Today we will speak about some introduction, fundamentals of measurements. So the measurements meaning that the science of determining the values of physical variables. So I have a value, a physical value like the mass, like the voltage, like the temperature, and I want to measure it. So measuring meaning that I have some result information regarding or corresponding to this value, so of a given quantity, and this value is measured according to some standard or some corresponding units that I use to measure this physical value. And using how I can measure this, I measure it using some instrument, a device in that used to measure the value, this physical value. Of course, there is various types of devices corresponding to various physical value or physical variables around us. The result is expressed in numerical value. So you measure the temperature using, for example, Celsius. So you say that it is 37 Celsius or 36 Celsius. So it's a number, and you express it corresponding to this quantity. Okay. Now, physical variable like temperature, pressure, light, displacement or speed, whatever. So why I do measure? I measure to maintain a proper operation. For example, in the hospital, the doctors and nurses measure the temperature so they can decide if there is a fever or not, or something else. So they also measure because they want to improve the quality of a product. For example, there is a quality of a product that is you want to produce a product, and you want to ensure that it's giving the correct output, and every steps of your product it giving you the correct output to improve the efficiency of the production. For example, the production line at some level gives you some errors, so you measure use some devices to measure what I have here. At this point the box weight 2 kilo, for example. At this point it weight 2.5 kilo. So why this 0.5, if it is accurately correct or not, and you later you decide if it is correct or this is correct standard, for example. So measurement is very important in industry and manufacturing. In the history, there is a lot of development in the measurement devices, or the measurement in the history of measurement. They used to use the human body as a standard or a level of measurement, or as a instrument. Then they use the cubic or Rubin, or they used various devices like you see here. So they used, for example, the need come from measuring the quantities of the food and the quantities of the jewelries, on, for example, diamonds here. Then they introduced a standard all over the world. They first make it as according to some level of lengths that will not change a lot. For example, in 1916 they make it so in 1960 they introduced a standard meter. They redefine it with the 1.65 multiplied by 10 to the power 6 of the wavelength of the radiation from krypton in space. They redefine it later as light travels, the distance that where the light travels 1 over this number of a second. So any value around us, they define it according to something. For example, here the 1 centimeter cubic, 1 centimeter, 1 centimeter, 1 centimeter, it's the definition of 1 gram here, 1 gram. So they define everything around us according to something, according to a standard. So here this is a prefix before what we name it. If we have 10 to the power 3, 1000, we name it kilo. 10 to the power 6, we name it mega, 1 million of something, of meter, of kilogram, of liter, whatever it is. So this is the prefix we put it before, and this is the symbols. So it is from deca, hecto, kilo, mega, and in the other side 0.5, 0.1, 0.01 centimeter, millimeter, micro. So this is the prefix that we put it as a standard of metric. Now the SI here is standard coming from SI unit, SI Systems International Unit, which have two different units, fundamental unit and derived units. Fundamental meaning that they have, we can measure it in its own value. Length we measure it in meter, mass we measure it in kilogram, time we can measure it in second, and this is the symbols. The symbols we put it in equation, and it's like abbreviation. Instead of writing the whole word second, you just put S, the temperature, the whatever it is. So the derived units, it's a unit that you build up from one fundamental. For example, the area we measured at the area of a square. It is the two dimension multiplied by each other, so it's meter square, so it's square meter. A volume, it's cubic meter. A velocity, it's meter per second. So this is built up according to a formula of using the fundamental units. Okay, so different quantity have a different standard unit and have a different symbol and have a different formula to calculate, so it's not measured in its own. Okay, examples of the standard body. What is standard body? These standard units and these values, there is some people come together to organize how we can measure for the meter, or how we can measure the voltage, how we can measure that. These are some of these standard bodies: International Organization for Standardization, International Electrotechnical Commission, and American National Standards Institute. So this is like a institute of Turkish standards. This is an institute. It's related to organize the standardization of the fundamental units in internationally or inside a national countries, for example. So the international standard defined by the international agreements between some countries, or within some countries. So here I have some simple closed loop. So for example, to control the room temperature according to something, according to a reference value. So here is the room, here is the heater. I take the value of the room temperature, I measure it, I have a value, I compare it with the reference measure. If so, there is error, so I give the error to the heater. For example, you want the room temperature to be at 20, and now when I measure it, it is at 19. So the difference is 1. So the heater have to heat 1 only to until it be 20. 1 difference, only 1 Celsius, for example. And this is a very simple closed loop control system of any to give you an example of why we measure something, for example. So in real world, we have the space around us. We have a sensor to measure something, and we have a system that makes some calculation, makes some measurement, makes some error correction, for example, and then it gives you some output giving you to an actuator, maybe a motor, for example. You control the speed. You see in the speed area that this is above 80, for example. So you just remove your foot from the benzene or petrol, so the motor take an action and reduce its speed, so you keep the speed at 80, for example, or the speed of the street. So this is the real world connection between the measurement using some sensors and the actuators, the act. Even the actuator, maybe some human interaction and human machine interaction, or a machine directly. Okay, so here let's say some terminology. Measured, it's a physical quantity that I measure using some instrumentation. Calibration, it's that I have an instrument and I want to make it according to standards. So I want to make this device measuring this quantity according to a standard. There is no some errors happen in between. Test instrumentation, so you have like you gathering some data and you make some tests. So making some test in a development phase, for example. So flight test instrumentation, or testing and approving aircraft, for example. So you test every step for the flight, in a flight from the departure to the arrival, so you understand much better how is everything work and if it is working efficiently or not. If there is some error, where is it, where it come from, how to correct it. That's it. So now the transducer, a transducer is like some instrument that convert one form of energy to another. So it's convert one form of energy to another. Electronic transducer, it's have input and output electricity or electrical in nature, and give you the other side mechanical, for example, or temperature or whatever. A sensor, like I said, it's an electronic transducer that convert some physical quantity, temperature for example, to an electrical signal. So I see it in the screen. Actuator, the other side, the inverse of a sensor. So it converts the some signal in electrical energy to the mechanical energy. So it's giving for like the motor, for example. Now signal domain. What is I signal? What is I can measure or can introduce or can convert from electrical to energy? Magnetic energy, mechanical, thermal, optical, chemical. The transducer here, the sensors, may be radiation or mechanical, thermal, as like I said, and it converted from this value or this type of energy to electrical. What I see here the information. What I seeking about is the information that's in these quantities. So I want to see what is the temperature of the room, so I can decide if it is very high or very low. So I measure it in a value. This value, it is electrical value. Okay, so I can process it and store it, for example, digitally. Okay, now this is for example, I measure here using the sensor, and then the conversion to a voltage, then the processing here, for example, like the camera capture optical values in each pixel and then convert it to electric signal. So you can store your picture, or you make some processing in in the design programs or softwares. And then maybe you can transmit it to a remote point or other stuff, for example for storing or presentation in the screen, for example. So it's different. You return back and convert it to maybe a storage in, for example, you store the picture in a compressed version or a large version maybe. So there is a lot of operation and processes that you can put and you can make on the device. But in the original, this is a value, a variable that's physically measured. Okay, so this is the end of the lecture. Thank you very much for listening.